Assalamualaikum and hi. My name is Nordena Hazwani binti Abdurrani. My matrix number is CE 200-201. Today I will be presenting about my PSM2. My title for this PSM2 is Smart Building Monitoring System. A Smart Building Monitoring System by Cyber Solution Technologies. So I will proceed about the introduction. So this is the hands-on that I installed in UTHM most. Right, my problem statement for this PSM2 is inefficient appliances management in building while leveraging the smart city concept to optimize the monitoring appliances. Number two, an effective appliances control. So in this project, the objective is number one, to design, control, and monitoring system for the indoor smart building application. Number two, to develop the system prototype using IoT analytic platform. Number three, to integrate the developed system with the suitable dashboard technologies for indoor building applications. So next, regarding the background of the smart monitoring system, the smart cities has become a global aim for the industrialized countries in the post-industrial revolution period, which has the progress to IR 4.0. All right. So the promise of the industry 4.0 has become faster, smarter, more sustainable productivity. This is because it may aid in increasing efficiency and reducing waste. So the scope of the study is number one, use ThinkSpeak to collect, store, analyze, and visualize sensor data in a real time. To switch on or off the light for range supported by IoT device. Number three, to trigger the light to turn it on or off the switch purpose. Okay. Regarding the IoT dashboard, is a web-based tool that allow users to monitor and control connected device in a real time. So one of the main challenge of the implementing IoT dashboard is need to handle large amount of data in a real time. Right, so which can require efficient data storage and retrieval, as well as the efficient data visualization is a technique. All right, this is regarding the block diagram of the purpose system. So we used a Raspberry Pi, temperature sensor, humidity sensor, air quality sensor, ESP32, relay control, power meter, communication interface, and user interface. This is the dashboard platform used to control and monitor the switch. So this is the number of most configuration. So hereby they have the analytic tab, manage tab, display platform tab, and switch tab. So in my project, I will just focus to the switch tab, right? So this is the smart building monitoring electrical safety box PLA and relay. So user will be able to view the data in a real time. So they perform the data analysis and create the visualizations. Right. So this is the PLA box and the relay. Right. In the box, we also include the terminal block output 240 volt AC, and then we also use power AC to DC converter, 240 AC to 5 DC, right? So we also use ESP32. We use 8 relay. So in this situation, I just use 2 relay to control the light. So I just control 2 light in this situation. So in future, if I want to control more light, it's okay because I already insert 8 relay in this project. And then we also use Raspberry Pi. We use a voltage sensor and current sensor 24 AC. All right, this is the Blinks dashboard. Is where user design the graphical interface of their mobile applications. All right, so it allow for the creation for the buttons, sliders, graph, and the other widgets to control the visualize connected device. So the Blink supports a wide range of the hardware platform, including the popular microcontrollers, just like Arduino, Raspberry Pi, EST32, Practical, and others. So here is the setting up Blink. So we have the home, data, we can setting, and here is the switch to turn on or off the light. And then we also can look the reading of the temperature, the power, the voltage, and so on. Right. So this is situation when the light is off using the dashboard, blink dashboard. Right. So this is the condition when the light is off. Right. So they don't have any current value. They don't have any power value. And we also can read the temperature, the humidity, pressure, and air quality. Right. This is the situation when the light is on. So in this situation, I just switch on one light. So one light require 0.55 ampere. Right. The power is 136.24 watt. Right. So this is for light one is on. And then this is the situation when the two light is on. Right. So the current is increasing and the power is increasing. So when I turn on two light, the current reading is 1.23 ampere. Okay, this is a graph for the air quality. So this is the maximum value 170. The 170 is not in a good condition. The VOC is a 170. It's not in a good level. So the minimum one is 105. So 105 is in a good situation hazard level, right? So an air quality graph is a visualized a representation of the level of the various air pollutions or pollutants component of the atmosphere over the specific period. Right? So this is the condition where the graph is in the graph of the air quality in 1 hour. All right. Okay, this is the output current. So the graph typically plots the current measured in amperes along the y-axis and the time along in the x-axis. So this is the graph. This is the graph of the current. Is viewed live. So once we turn on the light, the graph will reach the maximum level because we just turn on, right? After a few seconds, it will be accurate like a normal range current reading. Example like 0.419, and then it will increasing a little bit, 0.423. It's not like increasing a lot, but it's a minimum and maximum value. Right. Next, output of the humidity. So for the indoor environment or control setting, the humidity graph are useful to monitor and manage the indoor air quality. Right. So here is the reading of the graph in 1 hour. So when the temperature is increasing, the humidity is decreased. When the humidity is decreased, the temperature is increased. Right. So this is the light control GUI, where user interface design that allow user to interact with and control light system in a user-friendly and visualized intuitive manner. This type of interface commonly used in a smart home automation system, right? The light control system and the other environment where the efficient and convincing control of the light is desired. So here is the platform direct from the dashboard. When I click on the dashboard, right? When I click switch tab, it will automatically trigger to the light control GUI page. So from this page, I can control the light to turn on or off the light, right? So this is the display when I connected the box PLA to the Wi-Fi. Right? This is the electrical safety box PLA connected to Wi-Fi. When the box PLA is already connected to the Wi-Fi, it will display that Wi-Fi is already connected, and it also display the IP address. Right? So this IP address is 192.168.1.120. Right, next is the test review of electronics load. So from the box, PLA box, it also can display the temperature reading, humidity reading, air quality reading, voltage, current, power, and usage, right? So, in conclusion, in practical terms, this is the Sopitical system finds application of diverse environments. So, from the smart home and the office of the industrial setting, where the optimized energy consumption are creating the peroxide light experiments are paramount.
Okay, betul.
Right, so this is the video demonstration regarding the switch on or off the light.
Barometer, barometer.
This is when the light one is on.
Camera,
Okay, now I turn on switch 2. So the light is on.
so I already know customer now.
Okay, now I want to turn off the light 1. Right, the light is already off. And then I want to turn off the light 2. Okay, now the light already off. So this is the display of the PLA box. Okay, it also can review the electronics load. So it's reading. So here is the relay where when I turn on the first light, all right, so the light at the relay will turn on regarding which light I turn on. When I turn on the light 2, the light on the relay will turn on. The second light will turn on. Is regarding which light I turn on. So I just can look over, like when I turn on switch 1, at the relay the light 1 is on. So it's mean like I already turn on the light 1. Okay, here is the copyright ACT 1987, the copyright of voluntary notification regulation 2012. All right, so here is the certificate copyright. So the title of the work is a develop of a real-time system prototype for air quality and temperature parameters. All right, I think that's all from me. Thank you.